Hi, good day all of you. Welcome to our session. Welcome to our channel Intelligible Tutorials. In this today's session now we are going to discuss about the restrictions to domain testing. What are the restrictions of domain testing and what are the limitations of the domain testing now we are going to see here. So normally the domain testing has also its own limitations and its own restrictions as the other testing techniques can have. Okay, so what are the limitations or restrictions now we are going to see. The very first one is coincidental correctness. So what is the meaning of the coincidental correctness? Domain testing is not good at normally finding the bugs for which the outcome is correct for the wrong reasons. That means it's not good for finding the bugs where the outcome is correct, even the outcome is correct for wrong reasons. Okay, so this is not a good kind of the testing for such kind of situations. And one more thing we have to remember is one of the limitation of this domain testing is whenever we are having binary outcomes or boolean values, so the handling such kind of the values testing is also one of the drawback of bottleneck of this domain testing. So right outputs may be for wrong reasons. Handling such kind of the situations also it's very weak. And the next one, handling the binary outcomes also it is very weak. So these two are the very first restrictions to the domain testing. The next one, domain testing is basically an example of the partition testing. Actually, it is. So, what is the meaning of the partition testing? It follows the divide and conquer policy, divides the entire program's input space into some set of the domains, and all the inputs within a domain are equivalent in the sense that any input represents all the inputs in the domain. So, one input can we take if we take any one of the input, it represents all the inputs. Okay, so domain testing is very good example of this kind of the partition testing. That means the input space is divided into some set of the domain spaces and considers all the domains are equivalent. If we take any one of the domain, it represents all the domains. Next, simple domain boundaries and compound predicates. Okay, so compound predicate means the predicate combination of two or more predicates is obviously regarded as the compound predicate, in which each part of the predicate specified a different boundary or not a problem. Okay, so simple boundaries and compound predicates. Okay, so for example x, how it is handled, how it is regarded as the restriction now we are going to see. For example, x greater than 0 and x less than 17. Just specify two domain boundaries but by one compound predicate. Okay, as an example, a compound predicate that specifies one boundary, that is x is equal to 0 and y is equal to y greater than or equal to 7 and y less than or equal to 14. Okay, so the compound predicates can have very simple boundaries. This is also one of the drawback of this. Okay, simple domain boundaries and compound predicates. Having simple domain boundaries is one of the restriction, and for compound predicates is also one of the limitation. Handling values for the compound predicates is also one of the limitation. Next, functional homogeneity of the bugs. Okay, so what is the functional homogeneity of the bugs? Whatever the bug is, it will not change the functional form of the boundary predicate. Okay, so this is called the functional homogeneity of the bugs. For example, if the predicate is ax greater than or equal to b, the bug will be in the value of a or b but will not change the predicate to ax greater than or equal to b. Okay, so whenever we are having a predicate like a ax greater than or equal to b, the bug value will be in the any one of the variable like a or b. It will not change the predicate to ax greater than or equal to b. Okay, so functional homogeneity of the bugs. This is called as the bug. It will not change the functional form of the boundary predicate. It will remain same. Okay, so the next one is linear vector space. The linear vector space means the linear boundaries. Bad assumption because in practice most boundary predicates are the linear. Okay, so we are having the linear boundaries. not a that means it is also one of the drawback. We may have the boundaries of non-linear also. This is one of the drawback of the having linear vector space. The next one is loop free software. As earlier we have discussed this, domain testing is one of the testing technique that is loop free testing. Already we have considered it as a loop free testing. So acting on the loops is one of the drawback or problematic situation for the domain testing. The trouble with the loop is that each iteration can result in different predicate expression, which means the possible boundary change, domain boundary change. So whenever a predicates executing the loops, the boundary values will be changing. Okay, so these are also some of the restrictions of the domain testing. And these are the restrictions basically. Those are coincidental correctness and partition testing, simple domain boundaries and compound predicates, and functional homogeneity of the bugs, linear vector space, and loop free software. These are considered as the main restrictions for the domain testing. In the coming video we talk about nice and ugly domains. Okay, thank you for watching, and watch all the videos. Thank you.